Welcome everyone to today's session of NPTEL course Environmental Chemistry, and this is the fourth live session. Welcome everyone. I am Saptarshi Bose here, a PMR research scholar from IIT Madras. I hope you will enjoy this session like the previous one. So let's start. The first question we will try to solve it is related to one monoprotic acid dissociates in water as we know. So suppose the monoprotic acid is HA, then it is getting dissociated into H plus and A minus ion, and we know the pKa value, that is nothing but 3.29. Now the concentration of the deprotonated form of A minus ion and At, that is the total concentration of the A at equilibrium are 10 to the power minus 48 molar and 10 to the power minus 3.5 molar respectively. So now we have to calculate what will be the pH of the solution. So here are four options. I hope everyone will try to solve this as quickly as possible and write their answer in the chat section. I will wait for a few minutes and then I will go for the solution. I hope everyone is trying. Okay, let's go for the solution. So the answer will be D, which is nothing but this 2.01, right? So let's check how to solve this particular problem. So we know what is the concentration of A minus ions. It is given here, right? That is given here 10 to the power minus 48, right? And what is the total AT? So these are the given data, right? What is the total concentration of A species? That is 10 to the power minus 3.5. What is in the form of anions? That is 10 to the power minus 0.48 molar. And what is the pKa, right? So we know from the Henderson-Hasselbalch equation that we can write this equation pH equals to pKa plus log of A minus divided by H. So deprotonated and protonated form we are writing, right? And then we can form another equation that is nothing but the total A species concentration is equal to HA plus A minus. So in these two forms, it can be present in the water or in the solution, right? So either it will be in the form of HA with H plus H combining with H plus ion, or it will be as a single anion, right? So these are the two possibilities. So we will write HA equals to 10 to the power minus 3.5 minus 10 to the power minus 4.5. I'm just rearranging this equation and I'm getting what is the value of HA. So I can calculate the HA value, that is nothing but 3.003788 into 10 to the power minus 4 molar. And from the equation 1, we will go back to this equation 1. Okay, and we will put the values here. So I know what is the value of pKa. It is already given here. Now I have calculated the HA. So I will write the HA concentration here. And also I know this anion concentration, which is nothing but 10 to the power minus 48. It's also given. So from here I can calculate what will be my pH, that is nothing but 2.01. So I hope that everyone understood this particular problem, and then we will go to the next one. So this is related to the acetic acid dissociation in the water, and it is following the similar kind of path, that is HAC is getting into H plus and AC minus heated. Then I know what is the value of pKa, that is nothing but 4.76. The pH of the resulting solution is 5, so the concentration of the acetate ion at equilibrium is 10 to the power minus 2.3 molar. Now you have to calculate what is the total concentration of acetate in the solution at equilibrium. So pardon, this T will be at the bottom. So the total concentration of acetate, that's why there is a T. So you just have to calculate and quickly answer through the chat section. So you know that the pH of the solution is 5 and the concentration of acetate ion is given there, 10 to the power minus 2.3 molar. We know the pK value, just you have to calculate it. Okay, let's go for the solution. So the answer will be A, that is nothing but 10 to the power minus 2.1 molar. So we'll know how to solve this. So first there is some given data. So we'll check the given data. First one is the AC minus concentration, right? The acetate ion concentration is given here. Concentration of acetate ion at equilibrium is 10 to the power minus 2.3 molar, right? We know the pH and we know the pKa value. So from the Henselberg equation, we can write this equation. So I am repeating this equation once again. pH equals to pKa plus log, then the deprotonated and protonated form, ACV minus ion and HAC form I'm writing. And then I'm writing what is the pH of the solution, right? I know the pKa of this acid, that is 4.76. then log of acetate ion concentration, and I will calculate what is the concentration HAC uh, form, right? So uh, from here I can calculate what is the concentration of HAC easily. So it is nothing but 2.884031 into 10 to the power minus 3 molar, right? So from the component balance, you can write that ACT total, the acetate ion concentration total, it can be in the two forms, right? So it can be with HAC or acetate ion form. So what you will have to do is nothing but you know what is the concentration of HAC, just write it down, and I know from the given data what is the acetate ion concentration. So I am writing 10 to the power minus 23. So you will get what is the total acetate ion concentration in this solution, that is nothing but 10 to the power minus 2.1 molar, right? So I think it was a easy problem. Let's go to the third one. So again, pardon, this 10 to the power minus 8 molar, like 5 into 10 to the power minus 8 molar HCl solution we have, and we have to calculate the pH on that solution, and ignoring the ionic strength and assuming that the activity and the concentration will be same. Please try to quickly find out the solution. So let's go to the solution. So the answer will be 6.89. It can be in the range of 6.8, 6.75 to 6.95, depending upon your calculation. Mm. So I'll first say that the what was given here, it was given the concentration, total concentration of HCl was given. That much we have added, like 5 into 10 to the power minus 8 molar, right? So from this equation, like you can another thing you know that in case of HCl, the pK is very less, it's less than 0. So it's a normal environmental condition. We can assume that there will be no actual HCl total. It will be 0 at equilibrium. Everything will be dissociated, right? So I can write the species here for particular this solution H plus Cl minus ion will be there and OH minus will be present as it's in the water solution. Then we have to select the components here for VMinTech software application. Now we will move to what is the problem solving using VMinTech software. I hope you all of you have downloaded this software as professor told you to download, and you already installed and you are trying to solve the problems using this software. So basically from now on we will try to solve using this VMinTech software. So the first thing we will suggest to think about the components, right? So we need to find out what will be the components. So from here, I can see that H plus already Professor told what is the reason behind this why we are taking H plus. So it can encompasses this OH minus also. So either H plus ion can stay in the form of, from this equation it will be more clear. Either it can stay in the form of H plus ion or OH minus one. So the H hydrogen, the total hydrogen concentration can be in these two forms. There cannot be in other forms, right? So when we are taking this H, then we are also counting these forms, right? And already HCl is totally dissociated. So, and then I will find that Cl minus as another component. So here you can see that this is nothing but H plus minus OH minus. So whatever H plus ion was there, and then we are subtracting OH minus ions, right? Then we are getting how much H is there. And that is the total H form. And also this is nothing but equal to HCl because HCl is the only source, right? So everything, the hydrogen present here will be total hydrogen concentration will be equal to this input HCl concentration, right? This is the only source. Again, in case of Cl, from where Cls are coming, obviously from HCl, this is the only source. So it will be equals to, so total Clt equals to Cl minus because there is no other form with HCl because everything is dissociated. That's our assumption, right? So there will be no HCl form. Everything is in the form of Cl minus, and that is nothing but equals to the initial input. That much of acid we have added, right? So we will solve this. Yeah. Okay. So we'll solve this. Okay. Let's check. Yeah. So here I can write this, right? Here I can write this from this equation I can write HT. This is total HT. Already I already discussed this is nothing but H plus minus OH minus equals to whatever input I have given, right? So you can write this thing in a different way. That's what we are going to see. So here I am writing H plus ion. Then I know what is the constant for water. Constant for water Kw. We know what is the value of Kw, right? This equilibrium constant for when water is getting dissociated, and it will be nothing but 10 to the power minus 1 for 40. And from here we are getting this. I think you all have gone through the concept behind the pH, why we get pH in the range of 0 to 14. What is the reason behind it, and how this 14 number is actually coming? Like everyone knows that the neutral pH is 7 and is going towards 0, then it will be acidic, and when it's going towards this 14, it will be basic. But why this 14? Why this 0 and 14? So I hope that you know what is the total concentration of water, like what is the total concentration of H plus and OH minus ions in the water it can be. So from there we are getting this Kw form. So I will not discuss again further about this Kw because it will go into the theoretical discussion. So let's try to solve this problem. I will suggest like everyone to go through the lectures and you will find how this Kw is related to H plus and OH minus ion and why we are writing this 10 to the power minus 14, right? So we know that for water it will be 10 to the power minus 14, and just you have to calculate. So it's a quadratic equation. You just have to calculate the H plus n, right? And if you just calculate the H plus n, I am getting this H plus n calculation as 1.28077 is a huge number into 10 to the power minus 7, right? So this is the concentration of H plus ions. So now I will calculate the pH. It is nothing but negative logarithm of H plus ion concentration, right? So I will write the negative logarithm, then I will put this value here, the H plus concentration, and I'll get this pH as 6.89. So hope this is clear. Now then we will move to the next question. So this next question is, okay, so this I think from this question we will try to go through this Beamentech. So let's see, a solution is formed by mixing an equal amount of H2SO4 and Na2SO4 in water, right? So the initial concentration of H2SO4 and Na2SO4 are 10 to the power minus 3 molar and 10 to the power minus 4 molar respectively. So assume both the compounds dissociate completely and can be neglected at equilibrium. So you have to find out the pH of the resulting solution. So I will suggest everyone to use the Beamentech software to calculate this particular problem. So two different chemicals we have added, we have mixed. That is, one is H2SO4 and another is NH2SO4, sodium sulfate, and this is the H2SO4 acid, sulfuric acid we have added. Now the initial concentration of sulfuric acid in Na2SO4 are 10 to the power minus 3 molar and 10 to the power minus 4 molar. That was the initial concentration. So assume both the compounds dissociated completely, and then we can neglect that it can be neglected at equilibrium. So find out the pH of the resulting solution. Try to quickly solve this and try to give the answer to the chart section. Okay, we'll go for the solution now, not wait anymore. So the answer is D here, and this I'll tell you how to solve this. So from here you can see that H2SO4 concentration was 10 to the power minus 3 molar and Na2SO4 concentration was 10 to the power minus 4 molar. Like these two are the given data, and then the species we can say that is will be Na plus. That is our assumption. This uh, species will be present there. You have to grow this intuition or this understanding to write down the species, which is very essential for using this beam intake. And then I'll write this SO4 2 minus will be also coming from this and this. From these two chemicals we are getting SO4 2 minus. We will get H plus ion and OH minus ion. So component, in case of components, we all know that H plus will take care of OH minus also, and we are writing this Na plus and SO4 2 minus. So we'll go for the tableau, and in case of tableau we will find that there are like 3 in case of Na plus. So we have to get one Na plus here. So no need SO4 2 minus. Already if you have gone through the lectures, you know. So how we are calculating, how we are preparing this tableau. So SO4 minus is not required for Na plus, then H plus not required, O minus not required, H2SO4 not required. But in case of Na2SO4, we are getting 2 Na plus. So this is very interesting, right? So in case of SO4 2 minus, I'll write in the similar fashion. So SO4 2 minus will be 1 and not required here 0 0. This will be 1. From H2SO4 I will get 1 and from Na2SO4 I will get 1 SO4 2 minus. In case of H plus, we can see this is 0 0 1 and this is minus 1 because H plus minus OH minus will give you the H plus total, right? So this is the equation, that's why I'm writing minus 1. And from here H2SO4 we are getting 2H plus and from Na2SO4 we are getting 0. So right now we will form the equations like Na total Na will be nothing but 1 multiplied by this Na and it will be equals to 2 of Na2SO4 because this Na2SO4 is the only source here, right? Na2SO4 is the only source in the solution which is providing the Na. And how many Na ions we will get from one Na2SO4, or in better to say that how many moles of Na plus ions we will get from 1 mole of Na2SO4. Obviously 2, I'll get 2. See, this is the 2. So for this 1 mole of Na2SO4 will give you 2 moles of Na plus ions. This is the fundamental thing you have to take care of. This is the important and the interesting fact. Okay, so I'll write 2 multiplied by 10 to the power minus 4. Whatever Na2 plus Na2SO4 is there, it will be twice in case of Na plus ions because 1 molar is producing 1 mole is producing 2 moles of Na plus ions. This is the fundamental understanding. In case of SO4, what I'll get? I will get for 1 SO4 2 minus, and this will be nothing equal to nothing because everything is getting dissociated completely. That's our assumption, right? So there will be no other form present here with H or Na or something like that. So I will get uh, yes, from what is the source now I have to think about. Source is H2SO4, so I'll get from 1 multiplied by H2SO4, and here also from 1 Na2SO4 I am getting only 1 SO4 2 minus, right? That's why in case of here 1, in case of here we are getting 2, right? 2. That's why I wrote 2 and multiplied with 2. Here I am getting 1, only 1, and that's why 1, and I am multiplying with 1. So just write down from here, these are the values. Write down and you can calculate the SO4 minus 2 SO4 2 minus concentration. Then I will again write for each total and I'll write H plus minus OH minus and then twice from H to SO4 I'm getting twice, right? Twice H plus ions. So I'll calculate that much of concentration I'll get for HT. Now we will give the input in vMintech software. So this will be the interface. I hope you have gone through it, like Professor told how to go to the first page, first interface, then give some inputs, and then just you have to write, find out the component's name. You can go for this calculated from this mass balance equation option. Go for that, right? In case of ionic strength, like calculate, just give it like that and then go for these components and just select the components and just try to input the values. The values I have calculated or you have calculated from here. You can change the units, that's in the millimolar, you can convert it into millimolar. See here, it's in the millimolar, that's why I have neglected all those 10 to the power minus 3, 10 to the power minus 4. Yeah, so I have converted it into millimolar. So just write down H plus was 2 molar, right? 2 H plus I was 2 molar, 2 into 10 to the power minus 3 molar, sorry, 2 into 10 to the power minus 3 molar. So it will be equals to 2 millimolar, right? So convert it, it will be 1.1 millimolar, right? So just put it down 1.1 millimolar, 2 millimolar, and zero point 0.2. Just back to the main menu and then just run this vMintech. If you run the vMintech, you will find out the pH. So pH is given as 2.756. That's the pH here, right? We'll get the ionic strength also, and this is our pH here, right? So now we'll go to the next problem. So this is a significant inhabitants in a city suddenly suffer from a waterborne disease. As being an environmental engineer, you are advised to check various parameters of potable water supplied across the city. Parameters include both chemical, biological. After assessing the influent and effluent of the water treatment plant, we found out a class of bacteria present in the water causing the outbreak in the city. Luckily, after laboratory testing, it was noticed that bacteria only survive in the alkaline water. So, to control this situation or to control this pH, 6 into 10 to the power minus 4 molar HPR propionic acid is added, so which reduced the pH of the water to 4.081, and that destroyed the significant population of bacteria. Now you have to neutralize this water for domestic purpose. So you are adding 10 to the power 3 into 10 to the power minus 4 molar of NaOH solution, and pH increased slightly. And for decreasing more number of H plus ion concentration, again 10 to the power minus 4 molar of NaPr, sodium propionic salt, you are adding to the water. So what will be the pH of the water? So there are few options. So please calculate it as fast as possible. You can use BMinTech software. So I hope everyone will try to solve this. So let's go to the answer. So answer will be A, and this is how we can solve this, right? So we are adding 10 to the power minus 4 molar of HPR and 3 into 10 to the power minus 4 molar of NaOH and 2 into 10 to the power minus 4 molar of NaPr. This is the given chemicals or the given data which we are adding into the water. These are the chemicals we are adding into the water. So first thing should be clear. Okay. Then like the H or hydrogen can be in two forms, either in HPR form or it can convert it into NaOH. So I am writing this either HPR minus NaOH. So whatever HPR we have added earlier, now NaOH is trying to reduce the H plus concentration. So there will be a direct relation. That was the reason, right? So we added some some acid propionic acid we have added in a certain concentration, that is 6 into 10 to the power minus 4 molar. Then H plus ion concentration was high. H plus ion concentration was high, and that's why the pH was very low. Now I want to neutralize it. I want to increase the pH, and I want to neutralize or I want to reduce the H plus concentration. That's why I'm using the NaOH. So whatever the balance will be there, right? So H plus ion concentration was high. Now I'm trying to reduce by using NaOH. So NaOH, the OH part will play a role here. That's why I am writing this HT in terms of HPR. So initially it was the contributor. Then I am using NaOH to reduce it. That's why I am writing as negative sign, right? So 6 into 10 to the power minus 4 molar, that much H plus ion was already present. Now how much it got reduced? That is 3 into 10 to the power minus 4. Now that much is neutralized, right? So I am doing this subtraction. So I'll get how much total H ions are present in any form in that water. So I'm getting 10 to the power minus 4 molar. In case of propanoate, what is the concentration? It can come from two sources, right? First is propionic acid, then NaPr. So I'm just writing. So this is the so for one propionic acid, I'm getting one propionate. So no need to multiply it with anything, it's multiplied with 1. So I'm getting 6 into 10 to the power minus 4. Then again from 1 NaPr, I'm getting one propionate. So it's nothing but 2 into 10 to the power minus 4 molar. So that much number of, that much concentration of propionate will be present there. So just add up, I'll get 8 into 10 to the power minus 4 molar. So in case of Na ions, I will write NaPr plus NaOH. These are the main contributor of this Na plus. So I'm just writing because from NaOH I'm getting one Na only, and from NaPr also one Na. So no need to multiply with anything. I'm getting this 5 into 10 to the power minus 4 molar. So I already discussed you how to give the give the inputs, right? So just write it down in a similar fashion. So write in case of H plus, what will be 0.3, right, millimolar, and this is propionate, and this is Na. So if you just give these inputs and go to this back to menu and just run this VM tech, you will find the pH is 5.104, or its equivalent to 5.11. So I can write this is the correct answer. So we'll move to the next question. This hydrofluoric acid is a weak acid, right? And we can see the pH. We can see the pH. Sorry, we can see the pK value 3.17, and that is used extensively in industry because Fe attaches firmly with Fe3 plus and Al3 plus ions. So that is the use of hydrofluoric acid in the industry. So as a result, it is an excellent reagent for removing surface scales, whatever the rust is there from the objects and made of iron or aluminium before they are painted or any other surface activities going on. So compute the pH in a solution prepared by adding 10 to the power minus 3 molar HF to pure water. So now you have to calculate what is the pH of the solution prepared by the adding 10 to the power minus 3 molar HF into pure water. So please try to solve it quickly. Hope you understood the problem clearly. So we'll go for the solution. The answer will be C, and we'll see how to solve it, right? So in case of so what was the hydrofluoric acid pKa? That is 3.17, right? And we added 10 to the power minus 3 molar of hydrofluoric acid. So this is the initial concentration HF naught, that is 10 to the power 3 minus 3 molar, right? And we are getting this that HT. This is the total hydrogen concentration. So hydrogen concentration will be in the form of H plus ions. It can be in the form of HF, right? Hydrofluoric acid form, undissociated. So whatever it is, the main source is HF naught. This is the initial acid we have added. So this is the only source. So the total H will be equal to the whatever HF concentration or the hydrofluoric acid initial concentration we have added. So it is nothing but 10 to the power minus 3 is given here, and this Ft will be in the form of either F minus fluoride ion or HF hydrofluoric acid. It can be in these two forms. It may not be dissociated completely. So we are writing in these two forms, right? And also HF naught will be equal to the F total or the state. Uh, why this is so? Because in case of fluoride ion also or any form of fluoride, it might be hydrofluoric acid. It is coming through from this hydrofluoric acid source, the initial which we have added. So we can, as there was no fluoride ion present before in that water, so whatever we are added from that only we are getting this fluoride forms, right? Whatever forms it may be in. So this is nothing but equals to N to the power minus 3 molar. So I'm getting two equations here, right? So I am getting two equations here. So V min tech we can get here. So you just first write here that what is the HT total H ion concentration, that is nothing but 10 to the power minus 3 molar, and then what is the fluoride ion concentration, that is nothing but 10 to the power minus 3 molar. So if you just give inputs in the V min tech software, that is with against to H plus ions and the fluoride whatever is there, how much present is there. I'm writing in case of millimolar, that's why I'm writing only one, because this is in 10 to the power minus 3 molar. So just convert into millimolar and just go to the back menu and then just run vmintech. So you will get this pH as 3.26, right? So this was our required pH 3.267. So that was our correct answer, right? So we will move to the next question. That is another numerical question. You have a flux in your laboratory on which the level is smudged. So you cannot read it properly, but you can read something. It was written as it was a solution of a monoprotic acid, which we'll call it as HX. We don't know what it was, at a concentration of 2 into 10 to the power minus 3 molar in a 0.05 molar solution of NaCl, right? So you measure the pH of the solution, you get a reading of 3.09. So now determine what is the pK of the acid. So here are the few options. Four options are there. You just have to calculate it quickly and write in the chat section. So I will not wait anymore. So let's go to the answer, that is B. And how we'll solve? Let's check. So the pH was how much? 3.09. That's I got, right? And so I can write what is the H plus concentration, right? So H plus concentration will be nothing but 10 to the power minus 3.09 molar. I hope all of you know what is pH. The pH is something X, then what will be the H plus, and concentration nothing but 10 to the power minus X, right? Molar. So this is a basic concept. Let's go to the given data. Let's check them. So HT, right? So HT, how I am getting? So I'm assuming this was HX. I don't know what is X. So and the concentration was 10 2 into 10 to the power minus 3 molar, right? So H will be similar. So if it is a monoproteinic acid, so there will be only one H plus H ion, right? One hydrogen ion will be there, another will be some counterpart, some anions will be there. That is X. We are saying we are assuming that as X. So only one from one monoprotic acid, one molar monoprotic acid, I am getting 1 molar of H plus ions, right? So, and in case of anion also, I'll get 1. So I can write similarly 2 into 10 to the power minus 3 molar, and it will be equals to 2 into 10 to the power minus 3 molar from Hx. And I know what is the Hx concentration. That was nothing but 2 into 10 to the power minus 3 molar, right? So I'm getting this Na or sodium concentration. Sodium concentration also given here. Check, yeah, 0.05 molar. So I'll get from 0.05 molar of Na plus and similar 0.05 molar of Cl minus, because we are getting those from NaCl, right? So we can write alpha naught equals to Hx divided by Xt, right? The total X concentration. And now I can write another equation combining all the H, that is Ht, total hydrogen will be Hx. It can be in the form of Hx, it can be in the form of H plus ion, also it can be in the form of OH minus ion. So Hx plus H plus minus OH minus 1. So that much of hydrogen is getting converted into OH minus, right? That's why we are subtracting this, right? These are the species. So I can write Ht equals to Hx. We don't know what is the concentration of Hx. We can write the concentration of H plus ion. I know what is the pH. pH is 10 to the power minus 3.09. Sorry, pH was 3.09. So H plus concentration was 10 to the power minus 3.09. I can write that easily. And I can also write what is the OH minus ion. Just you will find C. Total will be nothing but total will be 10 to the power minus 14, right? And from this 10 to the power minus 14, you are just writing 10 to the power minus 3.09. So subtract it from 10 to the power 3.09, right? So if you just see, if you just add this two, you will find how much. If you just add this two, let me tell you in another way. See, these are giving you this in another way. I am trying to explain it. So this was the constant. This was in case of OH minus, and it was in case of, you will get 14, right? This is the total concentration of H plus and OH minus ions can be inside of a solution. So if H plus ion concentration will be 10 to the power minus 3.04, so rest will be 10 to the power minus 10.91, right? So from there we are getting this 10 to the power minus 14, right? 10 to the power minus 14. So totally it will be 10 to the power minus 14. So if you just write it down, you will find out what is the and okay, you know one more thing, that is what is Ht, right? So Ht, we know 2 into 10 to the power minus 3 molar. So I am writing it as 0.02 molar, right? So you will find what is the Hx value, and then just you have to put here what is the Hx value. So alpha naught will be Hx, just put the value here, and I know what is the concentration of Xt, 2 into 10 to the power minus 3 molar. Write it down, you will find alpha naught. So if you know alpha naught, we know another equation like alpha naught equals to H plus, and H plus plus Ka. So you need to calculate Ka, only then you can find what is the pKa, right? So to find out pKa, first you need to find out what is the Ka value. So just write down this equation, and then you just have to, you know, what is the value of alpha naught, right? Put it here, alpha naught value, you know, what is the H plus concentration, you know, right? What is the H plus concentration, and what is the H plus concentration again here. So if you just put it down, you know, everything is known to you. What is the H plus concentration here? This known, everything is known to you. Just write it down, and it will find what is the value of Ka. So from there, yeah, you can find what is the pKa value. So K is 10 to the power minus 3.25. So K will be logarithm. So there will be log, and if you use the log, you will find it will be 3.25, right? 10 base, obvious, log 10 base. So I'll go to the next problem. This is the last problem. Again, you can use Vmintech. So cyanide and we know Cn minus is vital in metal plating industries because it can keep metals dissolved under conditions where they would otherwise form solids precipitate. To settle out the solution, it is essential to maintain pH greater than 10 to the power 5 in these solutions to minimize the release of toxic hydrogen cyanide as gas. So if a solution is prepared by dissolving 10 to the power minus 2 molar of NaCN in water, so select whether the below statement is true or false. The pH of the solution will be in the range of minimize uh, to, to minimize the release of toxic gas, true or false. So it is the true, right? So we are getting true. So we'll check how we are getting this true. See, in case of NaCN not, I am getting how much? This 10 to the power minus 2 molar, and there is no other source of Na plus and Cn minus in the solution, right? No other source of Na plus and Cn minus in the solution. So we can write that Na plus similarly equals to Na plus total Na, that will be Na plus only in the form, and this is nothing but NaCN not, the initial one. This is the only source, right? In case of Cn also, it is in the form of Cn minus totally dissociated. It is nothing but coming from NaCN not. So this value will be equal. I know what is NaCN not, 10 to the power minus 2, 10 to the power minus 2. If you just put this value into Vmtech, you will find the pH as 10 to the power minus 5.7, right? So this pH of the solution is greater than 10 to the power minus 5. So the release of the toxic gas will be minimized, right? So that was the statement was true. Thank you, everyone. I hope all of you have enjoyed this session. So we will meet on next Saturday at the same time. Thank you. Thank you, everyone.